In this video, we're still talking about the graphs of sine and cosine, but more specifically, what we are talking about now is transformations. Okay, and so our transformations means that we are going to see our graphs have a horizontal shift and or a vertical shift. So we have some new letters that we're going to add. Okay, and so here's our two equations, sine and cosine. All right, please make sure you write those down. Notice that again, we can interchange the y and the f of x because these are functions. They pass the vertical line test. Okay, now there are 5 kind of important things to remember. And this is all true if we have a non-zero real number for a and b. Because if a, right, is 0, that means your trig goes away. If your b happens to be 0, that means your variable goes away. And again, both of those situations are going to lead us to a horizontal line, which is what we don't want, right? We want those lovely smooth curves or kind of looks like that. That's what we really truly want. Okay. So we have noticed that in the first video, right, we have talked about amplitude, so how high and how low our graph is. We've also talked about period, 2 pi divided by the absolute value of b. So 2 new things in this is our vertical shift d and our horizontal shift negative c over b. Now, these 2 things, make a little note, are actually not as important to memorize. So not as important to memorize. I'm not going to ask you specifically what a vertical shift is or name the vertical shift on your graph, but you should be able to at least recognize that your graph has one or recognize that you have a horizontal shift, so to speak. And with your horizontal shift, it's purely not just your C value, you actually have the B attached to it. Now, the very last thing on our table is we see number 5. It says an interval containing one period can be solved or found by solving this inequality. So this one is important. So I am going to put kind of exclamation marks. Okay. Now, in this inequality, the only thing that we're actually going to change is the bx plus c. The 0 and the 2 pi do not change, okay? So we'll be solving, so solve for x, which means we'll subtract c to both sides. So we'll say 0 minus c, whatever that value is, and then we'll say 2 pi minus c, and then I'll divide everything by my b value. Whatever numbers I get, I'm going to get some number here, and I'll have x, and again, I'll have some number here. This is going to be the start and the stop of your interval, right? So we still want to find five little interval spaces. Okay. Now, once we do all that, this will help us figure out our x values. So how in the heck do we figure out our y values? Well, we have patterns. We have our sine pattern, and our sine pattern will follow 0, 1, 0, -1, and 0. Our cosine pattern is just going to follow the numbers 1, 0, -1, 0, and 1. Again, where do these numbers come from? They come from our unit circle, right? So these are your values for when we plug in 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi, right? So that's where those values come from. Okay, let's go ahead and erase those. Now, what we're going to do is with these patterns, you are going to multiply your pattern by your A value, right? So again, this is so we don't have to build a table. So we're going to multiply by your A value, and whatever we have for our D, we're also going to add it. So if I multiply A by 0, I'll just have 0. So my first number would be whatever 0 plus d is. 1 times a, this will just be a plus d, and then this would just be 0 plus d, aka just d, or I should say 0 plus d. And then this would become negative a plus d, and then another 0 plus d. Okay, so once those are, and again, the a value comes from this lovely equation right here. It's our first value. Notice that I didn't say amplitude. You're not multiplying it by the amplitude, you're multiplying it by the a value. So you might be multiplying it by a negative number. And again, cosine works the same exact way. I would multiply by a, add my d, so it'll just be a plus d. A times 0 is just 0, so this guy would just be d, negative a plus d, d, and then a plus d. So notice that my first and last numbers are always the same. Same thing on my sine pattern. The first and last numbers are always the same. All right. So now that we have an idea of what our patterns are, what we need to find, let's go ahead and graph some trig functions. So go. So came back. All right. So let's go ahead and we are going to graph, and we'll graph y is equal to, let's start with sine first, x minus pi over 3. And let's do this over just one period. So we'll start off easy and then work our way up for 2 periods. Okay, so the first thing that I want you to find still is our amplitude and our period. So our amplitude is the absolute value of A. So it's the absolute value of 1, so just be 1. And our period is our 2 pi divided by our B value, or absolute value of B. So 2 pi divided by 1, again, is just 2 pi. Recall that period is the length, right? It's how long your motion takes for it to kind of go through that whole up-down motion of sine. That would be 1 period's worth. If I want to continue, 2 periods worth, and so forth and so on. Okay. So what do I do? I need to figure out where I'm starting and where I'm stopping from. So I'm going to take my value in here, right? And I'm going to set up an inequality. And I'm going to put x minus pi over 3 in the middle, and then 2 pi. And I'm noticing that I wrote what's in the middle in red because that's what's going to change. Nothing else changes. The 0 always stays as 0. The 2 pi always stays as 2 pi. So what do? We solve for x. So I'm going to go ahead and I'm going to add pi over 3 to both sides. Now, 0 plus pi over 3, that's an easy one. That's just pi over 3. For the 2 pi plus pi over 3, we do have to do a little bit of manipulation. We can't just add them because they don't have the same denominator. So recall that 2 pi is really 2 pi over 1, multiplied by 3 over 3. So this is the same thing as 6 pi over 3. So 6 now plus 1, that will give me 7 pi over 3. Okay, now I said period is length. So that means that from the start to the stop should be the length of 2 pi. And if you think about this, if I was to graph, here's pi over 3 and 7 pi over 3. The distance between pi and 7 pi is 6 pi over 3, aka 2 pi. So again, that's our distance, start and stop. Okay. So how do I find the rest of my numbers? So let's go ahead and we'll take that away. We don't need that anymore. Okay, so how do I find the rest of my numbers? Well, I said pi over 3 is our starting. I have 3 numbers in the middle, and then 7 pi over 3 is my ending point. All right, so how do I find my numbers? So I want to find the average, so I'm going to find this one right in the middle. So I'll find that one first. So pi over 3 plus 7 pi over 3, I'm going to divide that by 2. So that would give me an 8 pi over 3 times 1/2. So that'll become a 4 pi over 3. I'm going to find this guy next. So number 2. So this becomes pi over 3 plus 4 pi over 3. Again, divide by 2. So this becomes 5 pi over 3 times 1/2. This time this doesn't simplify. So I'm just going to leave it as 5 pi over 6. Now, I am all about finding patterns, right? So let's use a different color. So how about this one? Okay, so I'm going to change everything to the denominator of 6. So pi over 3 would be the same thing as 2 pi over 6. 5 pi over 6, don't have to change. 4 pi over 6, this would be the same thing as 8 pi over 6. And then 7 pi over 3 is the same thing as 14 pi over 6. So the reason I'm doing that is so I know what increment to graph by, but also to help me out with number 3. So how do I go from 2 to 5? I have to add 3. And 3 plus 5 gives me 8. 8 plus 3 gives me 11. And 11 plus 3 gives me 14. So I have just found my missing term. That's if I didn't want to do it the same way that I did 1 and 2. So these are your x values. So how do I find my y values? So my y values are my pattern. So I take my pattern for sine, 0, 1, 0, -1, 0. I'm going to multiply it by my a value. I don't have an a value besides 1, so if I multiply this all by 1, it doesn't change anything. Then I'm going to add my d value. I don't have anything, so I don't have to worry about manipulating this pattern at all. So this purely is my y value. So what do I do next? All right, so the hard part is already done. So now comes the easy part. We are going to create some graphs. So let me create an x-axis and a y-axis. I'll put it right here. Looks good. Make it a little bit thicker. Awesome. Okay. And actually, I'm going to see if I can change the color. Change it to black. Still make, change the weight. Oh, perfect. Look at that. Look at that. All right. That's a decent looking graph. Okay. So what I want to do is I want to make sure that my increments are evenly spaced out. Okay, so I'm going to go by pi over 6. So I'm going to skip, and my first one should be 2 pi over 6. Now I can either write pi over 3, or I can write my 2 pi over 6. Either one, I don't mind. I'm going to skip 3, 4, and then this would become 5 pi over 6, and then 7, 8, 6, 7, and then 8. Pi over 6, and again I can write that, or I can write 4 pi over 3, 9, 10, 11, pi over 6, and I just realized my graph is going to be too small, so let's make it bigger. There we go. So 11, and then 12, 13, and then 14 pi over 6. All right, I'm going to go as high as 1, so let's make 1 up here, make -1 down there. And now we're just going to plot our points. So pi over 3 is my first number, and let's plot that in black. So pi over 3, it gives me 0, so it crosses your x-axis at 0. 5 pi over 6, that's at 1. And then 8 pi over 6, we're right down to -1, so we're down here. 11 pi over 6, we're at 0. And 14, oh sorry, I just realized I made a mistake. Hold on. I skipped 0, so let me erase that. 8 pi over 3, sorry, this one right here, 8 pi over 3 would have been the third one, so that would have given me 0. This 11 pi over 6 is my fourth one, which gives me -1, and then I'm right back to 0. So I skipped 1, I apologize for that. So here is my 1 period. So again, make a nice smooth curve through your graph and connecting all of your points together. And that's it. That's all you have to do when we are graphing. This is to, again, to avoid having to use a table. We don't want to use a table. Okay. So let's try. Let's try another one. If you want to try one of these on your own, feel free to pause the video and try it, and come back and see kind of what I did. Okay. So here is our second example. You are going to graph y is equal to 3 cosine x plus pi over 4 this time. And let's graph this one over 2 periods worth. Okay, 2 periods worth. Go ahead, pause it, try figuring out what the amplitude and period is. And then if not, you can, again, watch the video. So our amplitude this time is a 3. Our period, again, our length, is still going to be 2 pi because our b value is 1. So what am I going to do is I'm going to replace my bx plus c with my x plus pi over 4. And again, I'm noticing I'm keeping my 0 and my 2 pi exactly the same. I'm going to subtract my pi over 4 to both sides. So 0 minus pi over 4 is just negative pi over 4. This gives you x, and this will give you 7 pi over 4. Now, there's 2 ways that you can get this answer. Again, you can multiply top and bottom by 4, which will give you 8 pi over 4, and then subtract pi over 4. Or, if you think about it, use your unit circle, right? It's there to your advantage. You know 2 pi goes all the way around, and then if I wanted to subtract negative pi over 4, I'm pretty much going to be in the 4th quadrant. So this would become a negative pi over 4. So in the 4th quadrant, your negative pi over 4 is the same thing as 7 pi over 4. So that's how I kind of did that work in my head. All right, so now what we want to do is find our intervals. So negative pi over 4, blank, 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 and our ending point, 7 pi over 4. So again, we're doing the same exact work that we did before. I'm going to call this number 1. So this will become negative pi over 4 plus 7 pi over 4. Divide that by 2. So this will become 6 pi over 4 times a half. So 3 pi over 4. So my second one down here. Again, negative pi over 4 plus 3 pi over 4. Divide that by 2. 2 pi over 4 times a half. And that just gives me pi over 4. Now, the great thing about this problem is that every single problem has a pi over 4, so I don't have to manipulate this. So negative 1 to 1, I have to add by 2. And 1 plus 2 gives me 3. So 3 plus 2, that gives me 5. So it looks like I'm pretty darn good with my intervals without doing really any extra work. So this should be my my x values. So there's my x values. So let's figure out what my y values are. So again, I'm going to start with cosine. The difference is now 1, 0, negative 1, 0, 1. I am going to multiply it this time by my a value. A value is positive, so multiply it by positive 3. So this becomes 3, 0, negative 3, 0, and 3. I still don't have a d value on this, so I don't have to worry about adding anything. So that ends up being my y value. All right, so let's go ahead, and I think I did the last graph over. Now, I'm actually going to make my x-axis quite long because I'm going to show you how we can create periods potentially in either direction. So I'm going to make this fairly long in case I run out of room. Okay, hopefully I don't run out of room. Hopefully this will need more on the positive side. Okay, so the first thing I'm going to do is I'm going to graph what I know. Okay, so graphing what I know as I'm going by pi over 4. So this becomes pi over 4. And then I'm going to skip. This is 3 pi over 4. Skip 5 pi over 4. Skip 7 pi over 4. I'm going to go as high as 3, so 1, 2, and 3. Low as -3, so 1, 2, and 3. Now you guys are using graph paper. You're probably going to be a little bit cleaner than my graph. And then I'll plot my points. Oh, and I forgot. I need to go one more because I've got negative. Forgot about my negative pi over 4. There we go. Okay, so negative pi over 4 is my first term. My first value is 3. So I'm going to make that connection right there. Pi over 4 will give me a 0. 3 pi over 4 gives me a -3. And then I start making my way back up. Okay. Now, it doesn't matter where you cross your y-axis. We're not really paying attention to the actual y-intercept. So you don't have to necessarily worry too much about that. But again, make your graph through a nice, smooth curve. There we go. So that is your first period. Now, for our second period, we can either continue this graph this way, or we can continue this graph the opposite way. It does not matter. Now, one way, you guys are going to decide one way is easier for you, okay? Now, for your 7 pi over 4, what's happening with your 7 pi over 4 is it ended your first period. It's got to start your next period. So what I'm writing up here is something that you don't necessarily have to write down, right? So it's our second period. But again, knowing your pattern, this makes life a little bit easier. So 7 pi over 4, this would become 9 pi over 4, 11 pi over 4, 13 pi over 4, and then finally 15 pi over 4. Notice the difference between the start and the stop is 8 pi over 4, which happens to still be our period. Okay, now how you can graph this without drawing this out is, again, you can just say, okay, 8, skip, and then 9, skip, and then 11. Do you have to write these numbers out? No, skip, and then 13, skip, and then 15. But writing them out kind of helps you figure out how many more terms you have. And then the pattern still follows the same thing. 3, 0, -3, 0, back up to 3. So whatever starts your graph, right, ends a previous period. So that's one second period if we wanted to do that. Let me change my color to a different color and show you again another possible period. Oops. Oh, shoot. There we go. Don't know what happened. Okay, so another possible period is that it ends at negative pi over 4. So if it does that way, I just got to go backwards. So again, instead of adding by 2, I'm now subtracting by 2. So negative 3 pi over 4, negative 5 pi over 4, negative 7 pi over 4, negative 9 pi over 4. So again, make that number skip, and I get negative 3 pi over 4. And then skip, negative 5 pi over 4. Skip, negative 7 pi over 4. Skip, ooh, just barely made it. So again, I started at 3, so now I'm going backwards. But again, it's 3, 0, -3, 0, and then we're right back up to 3. Connect it with a nice smooth curve. Hopefully yours looks a little bit neater than mine. So what's the colorful part of the graph is a possible second period. All right, let's try one more graph. Let's try, because we haven't seen one with a D value yet. So let's try one more. Okay. So third example, this will be our final example. Let's say graph f of x is equal to 3 minus 2 cosine of 2x. And for this one, let's just graph it over one period. If you want to do 2, we can do 2. And you can always check with me to see if your second is looking good. But for the most part, just 1 should be fine. Okay, now for this problem, well, my 2 looks weird over here. So for this problem, I noticed that the 3 minus 2 is in front. This value right here is your D value, right? D can either be at the beginning or at the end. It's whatever's being added to this. So I always like to rewrite this problem so that way it looks like the equation I started off with. So I don't want to subtract because order of operations tells us that we'd multiply things first. So I want to keep this this the way that it is, right? Actually, you know what I'm gonna do? I'm gonna change. I don't want these two numbers to be the same, so I'm gonna change this actually to a 3 before I begin. So let's keep that as 3, and then so we'll put this as 3x and then plus 3. Okay, so what does this graph look like? Amplitude. Now amplitude is a positive 2. Even though there's a negative there, again, amplitude's always positive because it's the absolute value. Okay, your period. Again, how long is your graph? This will become 2 pi divided by 3. I don't have to simplify that fraction, so I'm done. All right, so then we're going to set up our inequality. Now, notice how I'm setting it up. Notice that I didn't change my 0 or my 2 pi. I kept it the same. So just because, again, I found my period first, I can find my interval notation, my intervals at any time, okay? Your intervals will always automatically start with a 0 and end with a 2 pi. Don't change this value whatsoever, okay? So what do I do next? I'm going to go ahead and I'm going to divide this by 3. I'll divide this side by 3, and I'll divide this side by 3. So when I do that, this will give me 0, x, and then 2 pi over 3. Now, it might be good to note right here, right? You really only need the interval inequality when you have a C value. That's really the only time you actually need to use it. Everything else will always start at 0 and end at whatever length your period was. Okay, so, but if you want to use your interval inequality all the time, feel free. Okay, so how are we going to do this? Let's put it up here. So 0, blank, 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 2 pi over 3. So again, we're going to walk through this fairly quickly. So we're going to find this guy first. So number 1, 0 plus 2 pi over 3. Divide that by 2. This will give us 2 pi over 3 times a half. So this is purely just pi over 3. I'll do the second one here. So 0 plus pi over 3. Divide that by 2. So pi over 3 times a half. Again, that's the same thing as just pi over 6. I'm all for finding the same values. So let's go ahead and so this would become 0 pi over 6. This would become 2 pi over 6. So this one should become 3 pi over 6, which essentially can be simplified down to just pi over 2. And then this guy right here would be 4 pi over 6. So it seems that my intervals were good. So again, this is my x's. So my y's, again, cosine pattern. So it goes 1, 0, -1, 0, 1. I first want to multiply by my a value, not my amplitude. So notice that -2 is what I'm multiplying by. So this becomes -2, 0, 2, 0, -2. And I do have a d value, so I'm going to add 3 to both sides, or everything. So this will give me 1, 3, 5, 3, and 1. So this, my friends, is what your y is. Okay, so let's go ahead and graph our final thing. And again, it's positive, so this is not a bad looking graph. I feel like it's a little crooked, so let's fix it a little bit. There we go. Okay, so I only said one period. So let's go ahead and go by pi over 6 and spread this out. So this would become 2 pi over 6, or we could just say pi over 3, which is fine. And then this becomes pi over 2, and then 2 pi over 3. So either one. Okay, now I didn't actually need a lot of space on the denominator because I know that I'm going up high. So 1, 2, 3, 4, 5. So put a little 5 there. And let's go ahead and graph it. I'll change the color because we're getting close to the y value. So the first one is at 0. So 0 is going to give me 1. Pi over 6 is at 3. Pi over 3 is at 5. Pi over 2, we're right back to 3. And then we're down to 1. So my intervals are not necessarily spaced correctly, but we get the idea. Okay, graph paper would help us out a whole lot more. Okay, now notice that this graph doesn't cross your x-axis this time. Okay, so we don't have any x-intercepts while there are other graphs do. Okay. So that's how you graph now with not only your amplitude and your period change, but also now with a horizontal shift to the left or to the right, and with a vertical shift up and down with sines and cosines.